Hello class, welcome to Big Ideas, Chapter 1, Lesson 1. Today we are going to be learning about integers and absolute value. I need you to take out your hardcover textbook that you keep at home and open up to page 4. For this math book, you will need a math notebook or note paper to take notes on in order to receive credit for this video. Notes will be due in class tomorrow, so please make sure you have your notes as evidence that you watched the video. So today in class we learned about speed and velocity, and if you remember, speed tells us how fast an object moves, and velocity also tells us how fast an object moves. But velocity also tells us the direction, such as up and down. If an object moves up, such as a balloon, we say it has a positive velocity. But if an object falls down, then we say that the object's velocity is negative. Integers are whole numbers that can be positive or negative. Here are some examples, like -3, -2, -1, 0, 1, 2, and 3. They're all whole numbers. A whole number is not a fraction or a decimal. It's a whole complete number, and it can be positive or negative. So we will be using integers in our lesson today. Our key idea is absolute value. An absolute value of an integer is the distance between the number and 0 on a number line. The absolute value of a number A is written as the absolute value of A, shown with the bars here. I'm going to highlight this for you. Notice how absolute value has the bars around the value of the number. So to use absolute value, it's very helpful if we have a number line. A number line shows where 0 is located. So here is 0 in the middle. The absolute value of 4 here in blue is 4 units away from 0. So we say the absolute value of 4 is equal to 4 because you can count them 1, 2, 3, 4 spaces away from 0. Now let's look at the absolute value of -4 as seen here. When you count the units from 0, it goes 1, 2, 3, 4. It's also 4 units away from 0. So the absolute value of -4 equals 4. Now, absolute value is measured in distance, and distance is always positive. You cannot go a negative distance. And since distance is what we're using on a number line, absolute value must also be written as a positive value. So keep that in mind today as we do these examples. So example 1 is on page 4 in your books. It's called Finding the Absolute Value. And our directions say find the absolute value of 2. Now to do this, it helps if we use a number line. So go ahead and on your note paper, I want you to draw a line. And let's go ahead and label it with 0 in the middle. I'm going to just label some points on my number line like this. To the right of 0 is positive. So as you move right, the numbers are getting larger in a positive direction. And as we move left, our answers are negative, or our numbers are negative. So to the left of 0 is a negative direction. Now we have to find the absolute value of 2. So here's our number 2 here. An absolute value is the distance from 0. So if this is 0 and this is 2, I can count 1, 2 spaces over. So the absolute value of 2 is 2. It stays positive because distance is always positive. So once you graph 2 on the number line, you count how many units it is away from 0, and then you can show your absolute value, including the bars around the number 2. Very simple. Once you have this written down, go on to example 2. For example 2, we're still finding the absolute value. This time we're finding the absolute value of -3. So to start, let's go ahead and graph -3 on the number line. Here's 0. Remember, to the right of 0 is positive, so you have +1, +2, +3, and +4. To the left of 0 is negative. So we go -1, -2, -3, and -4. Now I'm going to graph -3 on the number line. So I put a solid dot here above -3. Now to find the absolute value of -3, I can write it like this: absolute value of -3. I need to count the distance it is away from 0. So here's 0. I'm going to count 1, 2, 3 spaces. So the distance from 0 is 3 units. Therefore, the absolute value of -3 is equal to 3. Now this time it was a negative integer, but since distance is always positive, the answer is also positive. Right now I want you to complete the on your own section on your note paper. You need to pause the video and complete questions 1 through 4. Use a number line if you need to. Okay, now that you're done with on your own, let's go on to example 3. This is on page 5 in your textbook. We need to compare 1 and the absolute value of -4. So the first thing we need to do is we need to graph these two numbers on a number line. Here is 0, 1, 2, 3, and 4. And to the left is -1, -2, -3, and -4. Go ahead and graph the number line. And let's go ahead and plot the point where +1 would be. +1 is to the right, so I place it there. Now, we need to compare the absolute value of -4. The absolute value of -4 means that it's 4 units away from 0. So it's equal to 4 because -4 is 4 spaces away from 0. Now, when we graph -4 on the number line, the absolute value of -4 is here to the right. Now that we can compare these two values, 1 is to the left of 4, therefore 1 is less than the absolute value of -4. So there's your sentence. You can look also in your book for the graph. At this time, I would like you to complete the on your own. So you need to show 5 through 8 on your note paper. Pause the video and tell me which statement is less than, greater than, or equal to. Okay, example 4 begins on page 5. This is our real-life application, and it's about the freezing point. It says the freezing point is the temperature at which liquid becomes a solid. So we have some substances. We have butter, and butter freezes at 35 degrees Celsius. Airplane fuel freezes at -53 degrees Celsius. Honey will freeze at -3 degrees Celsius. Mercury freezes at -39 degrees Celsius, and candle wax will freeze at 55 degrees Celsius. It says, which substance in the table has the lowest freezing point? So for A, I'm going to graph each of these points on a number line. So I'm going to say here is 0, and I'm going to move by tens, 10, 20, 30, 40, 50. And to the left of 0 is -10, -20, -30, -40, -50. Okay, so butter freezes at 35, so I'm going to plot 35 here in between 30 and 40. Negative 53 is down over here. Negative 3 is approximately here. Negative 39 is almost at negative 40. And 55 is past 50, in between 50 and 60. So now that I've graphed them, to find the lowest freezing point, I need to look as far left as our number line will go, which is this point here. This is negative 53 degrees Celsius. So therefore, airplane fuel has the lowest freezing point. Airplane fuel freezes at negative 53 degrees Celsius. I apologize for my writing on the smartboard. It's a little difficult to read. Just try your best to follow along. Now for B, it says the freezing point of water is 0 degrees Celsius. So you can use the absolute values. It says mercury or butter, which one is closer to the freezing point of water? So if this is a number line here, here is 0 degrees Celsius. Mercury is at negative 39 degrees, and butter is at 35 degrees. Looking at the absolute value, you look to see which one has a closer distance to 0. And because 35, the absolute value of 35, is less than the absolute value of 39, we can say that butter is closer to the freezing point of water because it is closer to 0 degrees. Now, I would like you to complete number 9. It says, is the freezing point of airplane fuel or candle wax closer to the freezing point of water? In other words, which absolute value is closer to 0? Explain your reasoning. You need to pause the video now to complete this activity. Now, on your note paper, I want you to work out this exit ticket. The exit ticket says the freezing point of vinegar is negative 2 degrees Celsius. Is the freezing point of vinegar or honey closer to the freezing point of water? Explain your reasoning. Remember, water freezes at 0 degrees Celsius, so you need to find out which one is closer to 0. Pause the video to explain your exit ticket. And for tomorrow, please bring your charged Chromebooks, your video notes from today's video, and also bring your record and practice journal. Write down any questions you have from the video, and please be prepared to ask them in class tomorrow. I hope you have a great night, and I will see you then. Bye-bye.